Hey guys, we're going to do some Khan Academy work here on powers of products and quotients. So in particular, you're dealing with two things that are being multiplied together. They could have the same base, could have different bases, or two things that are being divided. Usually they have different bases. And I think in most of the problems I've been doing so far, they all have different bases. But basically what you have going on is two things that are different bases in parentheses, and they're going to another power. And we're going to see how that all that kind of stuff kind of plays together here. So I'm excited to do some problems here. I think the best way to attack properties of exponents is just practice, practice, practice. You practice, you commit yourself to it, and you'll be doing a lot better. Basically, what's happening here is you have a base of a 2 and a base of a z. All right, those are two different things, so they cannot be combined at all. So you have two different bases here, and the 5 is the exponent that's outside of, or the power that's outside of the parentheses. So what's going to happen is this 5 is going to come down and it's going to hit every single thing. It's going to hit the -4, that power, and it's going to hit the -3, that power. It's going to hit every single power. And the rule for power to a power is multiply. So we have 2 to the -4 to the 5th. -4 times 5 is -20. All right. So the 5 multiplies by the -4 makes -20, and it sticks with that 2 for the base. For the other base, the base of z, same idea. You have a power to a power, so you're multiplying. -3 times 5 is -15. So we end up with z to the -15 power. So all that's happening is the 5 is coming down and it's multiplying the power here, and it's multiplying the power there. All right. Now that's a good answer. Notice it's not any of the answers here. This looks similar, but ours are negative, right? Keep in mind, we got to do some things with negative fractions. In general, we don't like negative fractions. So the best way to treat them is, if it's not a fraction, turn it into a fraction. All right. Anything that's negative, any power that's negative, that base has got to go to the other side of the fraction. Numerator to the denominator, or denominator to the numerator. It's got to go to the other side of the fraction. All right. And then it becomes positive. So this base has to go down here. All right. So in our new fraction, 2 is now in the bottom. The -20 power now turns into a positive 20 power. Z to the -15, same thing. If you want to make it positive, send it to the other side of the fraction, make it positive. Since everything on the top is gone now, we don't put a 0 here, because that wouldn't make sense, because 0 divided by anything is nothing. What ends up happening is there's a 1 here, because anything is the same thing as itself times 1. So if we get rid of these two things, you're still left with the 1 up there. That's the logic behind that. So whenever you lose an entire part of a fraction, put a 1 in its place. All right. And that will be our answer, which looks like it's option B. So some of these may have 2 or 3 steps to them, but that's okay. The best way to do it is just take it one single step at a time. Don't overthink it. Just kind of go, okay, one thing at a time. All right. We have a base of an X and a base of a 7. Different bases, they can't be combined. So your answer is going to have an X and a 7 in it. As you can see, all the options have X and 7 in it. The -7 is going to come down across the parentheses. It's going to hit that power, and it's going to hit that power through multiplication. So on top, you're going to have x to the -4 times -7 is -28 over -7 times -8 makes a positive 56th power. Is that a good answer? Do we need to do something with negative exponents? Yes, we do. This guy up here that's negative, that's no good. So what we're going to do is we're going to send the x to the 28th to the bottom, to the denominator. 7 to the 56th power, actually, well, I'll show you how the way that in our class, how I would like to write it. Khan Academy did it differently. What should happen, from my perspective, is x to the -28th is negative. We don't like negatives, so we're going to send it to the bottom. All right, x to the 28th, to the positive 28th. So to make this thing positive, we send it to the bottom of the fraction. the denominator. 7 to the 56 is actually, it's already a positive exponent. So it can stay down there. So 7 to the 56 stays on the bottom. On top, it turns into a 1. This is the answer that I would be looking for personally. However, if you look at the answers they have, that's not an option. The question, though, isn't necessarily what's the most simplified form. Khan Academy didn't ask that question. They actually said select the equivalent expression. So even though these are not, none of these to me are simplified correctly the way that I would want them to be, but they're still equivalent. And so they're not asking for simplified, they're looking for equivalent. We need to figure out which of these is equivalent to our answer. Notice how on this one right here, x to the 28th is positive and it's in the numerator. So I know for sure that's wrong because when it's in the numerator, it's a negative power. So that's definitely wrong. On the bottom, x to the 28th, again, same thing. It's in the numerator. That's no good. So it has to be b. And here's the reason why. What they did is when they got to this point right here, they moved this 7 to the 56th power up into the numerator. All right. So you end up with x to the negative 28th in the numerator. All right. Just leave this where it's at. 7 to the positive 56th power. What they did is they took it and they moved it up here into the numerator. And whenever you move it from the numerator to the denominator or the denominator to the numerator, you got to change its power, usually from negative to positive. In this case, from positive to negative. So then it turns into times 7 to the negative 56. So in this case, B would be the correct answer, B. Let's go ahead and take a look at two more. Let's see if they throw us any more curveballs like that. 6 and 8, two different bases. Negative 9 is going to come down and multiply by the negative 4. Negative 9 is going to come down and multiply by the negative 7. So you end up with 6, negative 4 times negative 9. That's a positive 36. Times negative 7 times negative 9 is a positive 63. And that should be the answer. Is that down there somewhere? The bottom one. C is the right answer. And clear this off. Here's our last one that we're going to do together here. You got a base of a 2 and a base of a 4, so the bases are different. That's always I always like to look at the bases and just make sure is there anything that can be combined to begin the problem. Down the road you'll see where you may want to think that way. 7 comes down and multiplies by the negative 10 power, and 7 comes down and multiplies by the positive 2 power. We end up with on top 2 to the negative 70 over negative 70 came from negative 10 times 7. 2 times 7 is 14. So you end up with 4 to the 14th power, which if you're doing it the way that I would like, you'd end up with 1 over 2 to the 70th power times 4 to the 14th power. Let's take a look and see, is that one of the options? It is. It's C. 2 to the 70th power, 4 to the 14th power. So this is the correct answer. Take note that in Khan Academy, they're not always asking for the most simplified form. They're asking for just an equivalent expression. So you may come up with an answer and say, my answer is none of these. It doesn't mean that your answer is wrong. It just means that your answer may not be one of the options. So now you need to figure out which of those options can relate to your problem. So that's more or less how you work with powers of products and quotients. Let's work on properties of exponents. Let's get better every single day, just one step better, and it'll make big payoff in the end. Have a great day, guys. Fight on.